Klangoo is a company that started off in Silicon Valley. So we were 4 students, 3 students along with our professor from AUB, Dr. Walid Saba. We started off doing natural language processing and natural language understanding research back in 2003. And since then, we went through several rounds of research. 2003 up till 2013, we were doing deep natural language processing research to basically identify what we call the aboutness of a piece of text. I'm going to go through that a lot during my presentation. 10 years later, whenever we saw that we have decent research results and we think we can go and have a product out of it, we regrouped, and each one of us was in a different country after 10 years, obviously, and we created this company called Klangoo. So I'm going to talk about what we have been doing and what we did in the past, well, now more than 16 years. So we started off working on these different building blocks, we call them in NLP. Now, Dr. Hazem explained a lot about what NLP is and what NLG is and what different types of well, he concentrated mostly on neural networks and the advancements on that end. I'm going to be talking strictly about text understanding, basically, more than anything else. So we had a main problem of basically trying to identify what a whole piece of text means up to what we call a semantic level. So really understanding what are the main topics of this text. This is used for many different purposes. You can use it for tagging just text, for search, for in legal domain, in the intelligence domain, and many different industries. You can use this particular understanding. Now, what we started with is basically try to see whatever existed in the market. And what we saw that everything that related to text analysis and semantic analysis did one particular thing at first, which is try to identify the main words that are being mentioned the most in a piece of text. This is simple, right? To understand better that text, they try to also identify what the meaning of that particular word was within that context. So if I give you, for example, the word line in the English language, it has 29 different meanings. So identifying what the word line actually means in a particular sentence is a challenge on its own. And this is what we call in NLP word sense disambiguation. Now, this is the problem basically that I'm talking about. So if I say I enjoy Jane's company versus Eddie's company is growing, these are 2 different meanings of company, okay? So this is the basic thing that you have to understand in order to be able to understand the full text. Understand at least each word what it means. We saw that this is the most that everybody did in terms of text analysis. So they stopped at the word level. They understand particular word, they understand what its meaning is, and they try to give it some kind of score. How? Using machine learning algorithms, using any type of algorithm, they try to get out a score. We understood from the beginning that understanding one word within the text does not allow you to understand the full text. So we went a step ahead, and we created what we call topics. What do we mean by topics? Topics are a combination of 1 or more words. Simple as that. You can place as many words as you want, one after the other, and then we'll create a similar object to a simple word. Okay, so let's say insurance claim. These are 2 different concepts. We combine them automatically into insurance claim, and we have the same representation of a word. In a semantic network, I don't know if I'm trying not to be very technical here, but is a lot of people around here technical? You're a little bit technical? What? Okay. So I'll just try to stay as high level as possible. So we had to create meanings first of words, what we call semantic network. So this semantic network, imagine it as a network of different dots. Each dot is a meaning, and each meaning has different words that represent it. For example, if I say mouse can have different meanings, right? So mouse can be the mouse of the computer. It can be the mouse, the rodent. Similarly, rodent and mouse exist in a semantic network, and they represent a particular meaning. If I say rodent or mouse with this particular meaning, you will understand what it is. So this is what we just saw with the company and company example. So having a representation for that in a semantic network was something that's very challenging. It took us 3 years to have a semantic network that we created on our own. It's a lot of work to have a dictionary of all the meanings that you can have in a dictionary, an online dictionary, digital dictionary, along with all the meanings. And then you have all the names. Go ahead. Yeah, rodent and mouse is a synonym for a particular meaning. So this is what we created. So there's a meaning. So the meaning is, I don't know, a four-legged mammal. Maybe this is the meaning of mouse. No, I'm looking at the meaning of the word mouse. Okay, so if we took now any dictionary, you have a word along with a meaning, right? And next to this meaning, you have synonyms. All of these synonyms basically relate to the same meaning. So we took just the meaning, and these synonyms mean nothing to us at that point in time, and we found out all the relationships between all the meanings. This is very technical. I'm not going to go into it. Just imagine there's a way to understand or to represent a word. Okay? Go ahead. Yeah. So, this is one of the main claims that we have in our patent. You can read it online if you're interested in knowing more about the details of how this exists. We have a US patent that includes 13 claims. This is one of the claims representing a word in a particular way. So it's very deep technical, but you can check it out and understand better how it's represented. For now, let's have a black box that represents a meaning, and this meaning has a lot of synonyms. First step that we did, again, we identified the meaning of a particular word within context. So company. These are algorithms that we spent on another couple of years, word sense disambiguation. Back in 2003, there was nothing close to what we did. Now there are a lot of companies that have good word sense disambiguation, but then the next step was to understand a list of words next to each other, what do they mean, and represent them in the same way as a simple word, as a simple meaning. So this was the main thing that we did. So again, back to the example of insurance claim and combining it into a single concept. I'm going to give you another example that will explain better what I'm saying. So company insurance policy is a phrase that appears in any text, right? What we do first is using this word sense disambiguation algorithm, that again, it's a patented technology of ours, we identify that in this particular sentence, company means an institution created to conduct business. And in our semantic network, it has an ID. This ID happens to be 702 FRD. And it's the meaning one of company. So company has several meanings, right? Similarly, insurance, we identified that it's meaning 3. Insurance means institution that promises payment based on a set of cases, rules. And similarly, policy, we identified this meaning for it. So we have an algorithm that identifies this. Next, we combine these 3 into a single concept. So it's a single meaning. We give it a new ID on the fly. This is what we call real-time topic formation. And we are the only ones that have this algorithm in the world. What we do in this is basically identify or combine, merge in an algorithmic way. It's an algebra basically that creates a meaning out of all of these meanings. All right? And we give it a score. How important was this topic within this text? You can combine so as many words as you want. So here we started with words. We ended up with concepts whenever we identified the meaning. Then we ended up with topics whenever we combined them on the fly with the same representation. The main purpose of doing that was basically to try to match any set of words together. So if I tell you now parallel universe, parallel algorithms, and multi-threaded computing, usually the easiest thing to do whenever you have a basic natural language processing algorithm is to match words, right? So I would match parallel universe with parallel algorithms. I would see that 50% of their words are equal, parallel, right? And similarly, with multi-threaded computing, 0 words in common with parallel algorithms and parallel universe. So maybe it does not relate. But in reality, we all know that, or whoever understands these sentences, knows that parallel algorithms and multi-threaded computing are much more related to each other. So we wanted to be able to match and identify the exact score of how 2 different topics are related to each other. Any 2 topics. And language is infinite. You can keep on adding words next to each other. I can say, the former Vice President of the United States of America, Joe Biden. I just stated like 15, 16 words, right? But all of these words mean a single thing. So that's the main purpose of what we did in real-time topic formation. So, given a piece of text, we first understand the first word, what it means, then we understand the phrases, all of these topics, what do they mean, and then we match all of the topics that were identified from within the text in an algorithm that we call topic analysis, and then we end up with this representation for a document. So we end up with a list of phrases that represent this topic, this document, and we end up in reality in our backend with IDs and scores. So the words mean nothing to us anymore. After we do the processing, this whole document is transformed into an ID, which is a meaning, and a score of how important this meaning was within text. Given this, we can now score documents, match documents, and see how related they are. So given any 2 documents, and by the way, our technology works in 107 languages at the moment. So you can give us any document in any language with any other document in any other language and match them, and you'll see an exact score of how related they are. So in this case, you would see a qualitative score, very related, somewhat related, or related, or not related. And then you have an exact score, which is like 32%, 100%, whatever. You can try this for yourself, by the way, using our demo online. Now, in this case, we added the traditional Chinese article and an Arabic article, and they were very related. This was an actual test. We were in a meeting with Chinese potential clients, and they wanted to see if if our algorithm works. They happen to know Arabic. They live in Dubai, and they have studied Arabic, and we tried this, and I took a screenshot. If you go to our demo, you can enter any piece of text in any language that you know and get automatically a summary, all the categories that this text belongs to. It might belong to more than one category. It might be technology and politics at the same time. All the names that were identified from within the text, and we identify 45 different high-level names, high-level types of names, and we have a long hierarchy of names that we identify. So for example, if Michael Jordan was mentioned, we will not only identify that Michael Jordan is a person name. We will identify that Michael Jordan is an athlete, he's a basketball player, he's a former NBA player, or shooting guard even. So we would identify exactly the role. Even if for the first time a name was mentioned within text, what a regular human would understand about this person, we would understand. So our engine would understand. So for example, if I say CEO Eddy Touma, our engine would identify that, okay, apparently this name relates to a CEO. Of which company? If we can identify it, our engine can identify it. This is the intention. And the key topics, so what I just mentioned, the different key phrases along with their meaning, and the score of how important they were within text. This is who we compare to in NLP. So these are, I'm listing here the top or the most known engines. They don't necessarily have the best technologies, but they are the most well-known technologies in the world. Google NLP, IBM Watson, what now is called Bluemix, more as a commercial name. It's based mostly now on Alchemy API, which was a previous company. Microsoft Azure, they call it Lewis. It's also an acronym. And Amazon AWS, Comprehend. You can see that we compare in different ways, in different areas. But the things that we have done most better, basically, are the categorization. In all sorts of places, we have languages more than 100 plus. What they handle is 10. At most 10 languages. WSD, very few do any kind of WSD. IBM Watson now is able to do some WSD, or at least they publicize it whenever they bought Alchemy API. But otherwise, in other things, we are basically much better. We have been compared, by the way, until now 10 times to IBM Watson, and 10 out of 10 times we won. So in 10 different RFPs, request for proposals, so a proposal to a client, 10 times out of 10, we won against IBM Watson, although their price is much cheaper than us. We are a startup, they are an actual company, huge company. So this is what we have been doing in the past 4 years as Klangoo. Again, we started off in Silicon Valley, and we wanted to find a first use case to this technology. So we have this technology, we have this great engine, what are we going to do with it? We noticed that the media industry is the easiest one to penetrate. They have particular use cases and pain points that we can basically fulfill. I'm gonna show you quickly, because I think all of you here have used our technology, but you don't know it, and I'm gonna show you how. And we ended up, after 4 years, accumulating all these clients. We have 15 different countries where we have clients in. So our product is called Magnet, and this is what we do. So if you've ever been on MTV website, for example, you have used us. So this Iqra icon at the side is generated by us. We understand basically all the articles, all the videos that they have basically published. We understand the text, this is in Arabic, and we identify what you would like to read next. We started off with 100 different algorithms for personalization, to personalize your experience. We ended up with using 16 out of them. So we use all sorts of things that you can imagine in order to personalize your experience. So again, if you went to MTV, each one of you will see a different set of articles in the Iqra icon, which is the recommendations basically. We identify every single consumption that you have done before, everything that you have read. We identify why do you like to read these articles? Why did you click on them in the first place? Maybe every time, for example, for me, every time I see in the title of the article there's the word Tesla, I click on it. So it just happens to be that I'm interested in Tesla without knowing. I'm not in the domain, it's not something that I would expect, but apparently I click on it a lot. And similarly, many other algorithms we use in order to identify what you would like more. If you went to Daily Star, similarly, the related articles, on MTV there are a lot of other things, but I'm showing you different places basically. Daily Star, related articles, the entities at the bottom, so all the names that are mentioned in the text. Then you have the follow and the recommendations also. So these are two other things. Let me just go back. So the follow this article, you can click on any article on Daily Star and follow this article. Basically, you are following the whole topic of the article. Any new article that is published on Daily Star that is about this same topic, even if it has 0 words in common with the current text, but it is about the same topic, you will receive an alert about it by email. For them, they chose by email. In other places in the world, we have alerts by SMS, by browser notifications, and so on. And the recommendations, similarly, it's purely related to you, not to the text that you are reading. These are the results. So what we help media companies with at the moment is basically increasing their page views, decreasing their bounce rate, increasing SEO, search engine optimization, and search engine driven visits, and increasing time on site. If you're in the domain of media, this is something that you care about a lot. I urge you to go on our basically website, try it out for yourself. You can go to developers, and if you're interested in trying out our API, and click on the Get Started Now at the bottom of the page and just start using our solution. Okay? Thank you guys.